going to learn about computers. Okay, computer basic architecture and its internal components and outside components. Okay, so we'll just go by questioning ourselves what is a computer and how the different things are connected to it. Okay, first, what is a computer, so that we can understand, because in everything is developed in a systematic. The problem we encounter will replace with some technology or some software so that it can be solved actually, like that you can understand more actually. So by intuitive way, if you start thinking, so which step, every step, why it is added to a computer, you will understand actually. So each and every modification, so that it can solve the existing problem, you can understand more as you go through this. So first we'll start from the basic step. Okay, what is a computer? Computer purpose. So computer, what is a computer? Computer is an electronic device so that it can process take the input and process. It's basically everything starts from the human need actually. So what is our first need actually? So we need a device so that it can process. Okay, process the data. It will take the data and process information and it give the results. Okay, it's like calculation or image processing or anything actually. So how does it happen actually? So first thing, so we need a device. So for that purpose, so computer is a processing unit. So for that, initially what we need to have, some processor. Okay, some processor. So what does it do? It will take the, what does it do? So in order to process, before it is a processor, it will do the processing of the data. Okay, so whatever the data we have to take in, so first it should take some input. Okay, after processing, it has to give the data to output so that user can understand. So output. Okay, so computer is an electronic device. It takes the data from the input and it processes the data and it gives the results in the output. So from this you can understand actually. So computer should contain a processor to process the data and some input device, so that it can take the data from the input, and output device so that it can give the results to the output. So you can easily understand actually. So computer architecture, so that we add one by one module which the way in which the computer works actually. So see here is the processor. Okay, after the processor it will process, but input, so that, see, computer only understands, you have to always remember, computer always understands only zeros and ones. Always understands and processes only in terms of zeros and ones. So either it is numbers or numerics or alphabets or visuals or photos, whatever it may be, all are converted into the format of zeros and ones. Okay, so everything, data is represented in terms of zeros and ones. Okay, maybe it is the way it presents to the output may be different, so that user can easily understand a image or whatever. Okay, you see here, so processor will process the data. Okay, for that it has to give the input. Okay, for example, you are for example, input devices. Okay, what are the input devices? For example, you take keyboard. Okay, output devices, you can say that monitor is an output device. So monitor displays the output data. Okay, in keyboard is we can enter the data. So in our computer should see every equipment, it should take the data from the input, or we should give the data and it should process the data and it should give the results also. Okay, so now see that if you keep on through the keyboard, you can enter the data, but it's not, human speed is very slow when compared to the computer speed, because computer works in nanoseconds, or very high speed actually. Okay, so if you press the keyboard and if we give instruction and every time CPU executes and it gives the display, what will happen? It is the very slow processing. Okay, it will take longer time to take each instruction. See, here we develop one by one actually. See, computer, through keyboard you are entering some instruction. Okay, like for example, in the machine language you entered add something, add b plus c. Okay, something like, I'm just roughly I'm giving. Okay, so after that you given next instruction, some other instruction, subtract. Okay, shift. Okay, if you keep on giving like this instructions, it will take, every time human gives the instruction, it will take and the computer will process and it will give the results. But here the problem is that human giving speed is very slow when compared to the computer speed, because human speed is in milliseconds or seconds around. For pressing, at least to press a keyboard it will take time. Okay, but computers works in so much fast. So what we need to have is that, and moreover, if there are, these are just 3 instructions. Okay, 3 instructions. See, computer will do whatever we instructed it to do. Okay, it doesn't, it has, nowadays they are giving artificial intelligence, but the computers usually do whatever we told it to do. Okay, so add, subtract. So if there are infinite, if there are multiple, for example, thousands of instructions, okay, so giving each one sequentially and seeing the result and connecting the result to the other one, it will be a problematic thing. So here now the new concept arrived, actually, memory. So why do we need required memory? Memory is nothing but it stores all the data. Okay, so this is stored program concept. Stored program concept. What is stored program concept? Stored program concept is nothing but, okay, stored program concept is nothing but, see, you give the instructions and data. So there are 2 things actually: instructions, data. Okay, see, add is an instruction. Okay, but values of B and C are the data. Okay, you understood? So add is a command or instruction. Okay, so computer should have instructions and data. So instructions and data will be there. So what will happen is that, so you should not keep on giving one by one through the keyboard. What will you do? That you will store the instructions and data in the memory. Okay, so instructions and data will be stored here. And data. Okay, instructions and data stored here. So what is the advantage of storing the instructions and data here? So that what happens is that if you store all the instructions, so that you no need to keep on giving from the keyboard, because if you give sequentially one instruction, for example, you give add B plus C, the processor will take it and it's execute that and it will print the output result. But if you give one by one in sequentially, it will take longer time. Okay, but processor works very fast. Okay, so human speed and process speed will mismatch actually. Okay, so that the result will take longer time. See, if you see in 1 or 2 instructions, you cannot differentiate. But if you see in lakhs of instructions, if lakhs of instructions are giving like this sequentially, it's highly difficult for the human to give. At the same time, processor, it will take the long time. Otherwise, you can do one thing. One best way is that you store all these, for example, 10,000 instructions. Initially store all these instructions and data in the memory. So what will happen? So computer can access the memory faster than human interface through the keyboard. Okay, so that memory concept arrived actually. Okay, in calculator, what will happen? You just enter the numbers and it will give the results. So it is taking the data from the human and giving the results. It's not like the computer, but computer is somewhat different. So here, what will you do? That you will store through the keyboard, you will store all the instructions in the memory. Okay, so that execution can be faster, because processor accessing memory it can access faster than the through input output. Okay, you understand that? See, processor, for example, I'll tell in terms of roughly I'll tell you speed. Processor, for example, processor works with the speed of this processor. For example, processor is a nanoseconds. Okay, memory is 10 times. If the main memory, you call it main memory, memory is 10 times slower. Okay, whereas input and output device is 1000 times slower. So see here, 1 time, 10 time, 1000 times. Okay, so there is a lot of speed mismatch because for example, it takes the input data, it just executes in 5 nanoseconds, but it has to wait for milliseconds here because, for example, in one, for example, take it in just in for example 10 cycles. 10 cycles means in terms of clock period we'll say that, because processor time will depend on the clock period. Clock means like this. This is one cycle, like this. Okay, if it is edge trigger, this is time period. Okay, in terms of clock period we'll measure it. Okay, so if it is, for example, if the computer takes to execute an instruction 10 cycles, if it is take 10 cycles like that, okay, synchronized with the cycles, okay, 10 cycles of the time it takes. For example, to read from the memory it takes 10 times more than, that means 100 cycles. Read from memory, an instruction stored in the memory, okay, whereas it takes 1000 cycles. Okay, 1000 cycles. From input output device or output device, okay, whereas it takes 1000 cycles. See that 1000 cycles, that means what does it mean? For example, just it takes 10 cycles to complete, but whereas it waits for 1000 cycles to get the next instruction. That means the efficiency of processor is fallen down by 10 by 1000, 1/10. So just 1%. So you understood now this thing. This way the processor, even though it can execute, for example, roughly you can say, even though it can execute 100 instructions, due to the speeds mismatch between input output device and processor, it is just executing, instead of executing 100 instructions, it is just executing one instruction. So that we have to always, the designers will focus on keep on improving the efficiency, speed, throughput, like that. Okay, so speed and efficiency can be improved by new concepts, at the same time new technology also, because for example take transistors. Earlier transistors are slower, again then comes the MOSFET, then ICs and everything. So as the technology of the device changes, again the speed will increase. That is one way of increasing speed. And also by doing the advanced concepts and research and doing things, also we can improve the, different of system designs. By changing system designs also we can improve the speed. Okay, improving the speed and reducing the size is the ultimate concept, and improving the throughput. Okay, so here see, so just it is executing through the sequential instructions, it is just able to execute 1% of its efficiency. So to improve the efficiency, we are introducing a concept of memory, stored program concept. Instead of giving all these instructions through input, we'll first store through input only, we first store all the instructions in the memory. Okay, for example 1 lakh instructions, we'll first store the instructions, all the instructions in memory, so that 1 lakh, for example 1 lakh instructions, all those are stored in the memory. Okay, so then what will happen, its efficiency will, so computer will fetch one by one instruction through the memory and it will print the results. Okay, in this way the efficiency of the device can be improved. So here this way the stored program concept arrived. Stored program concept, that means we'll store all the instructions in the memory, and computer will pick up the data from the memory and it will execute one by one, so that speed will not reduce. Okay, instead of giving from the input, we are giving this. So here what we have introduced actually so far, input device like keyboard and everything, output device, okay, and a processor and a memory for the stored program concept to store the instructions, and at the same time data. You know the difference between instructions. Add is an instruction, okay, B and C, some two values I'm giving some, add B and C is an instruction, but the values, what value B contains and what value C contains and what value B plus C after execution of the results is the data. Okay, you understand the difference between instruction and data? Okay, so this is the basic thing. So here we are having 4 things actually for the CPU: input, output, processor and memory. Okay, so we'll go more about this, each one we study more detailed actually. processor, the internal architecture of the processor, memory organization, input output device organization, and different peripheral devices. And also data representation. Data representation means computer can always understand zeros and ones. Okay, it doesn't understand anything else. But humans, as a humans, we have to see that pictures, audio, video, like multiple things. So everything has to be converted into a format of zeros, ones, and everything has to be reassembled in the format of the human can understand. Okay, so this way the computer works. So that is the data representation. And again, next concept is the programming. Programming means how we are giving the instructions to the computer. So how we are solving a problem actually, just like finding. I'll tell the more examples, more details actually. So this is the basic architecture of a computer. So how it is arrived actually. So there should be an input device so that it can take the input, and there is a processor, it can process the data, and output it displays to the humans are given in the either in monitor and whatever form human can understand and whatever form it can be used. Okay, and we also introduced a concept of memory. What is the purpose? Memory will store the instructions and data in the memory so that processor can pick up it fast. Okay, and in the future chapters we will see the different types of memory and different types of memory organization, and everything we'll see in more details. Now we'll go by one. So first we'll go for processor internal architecture, how it takes the data and how it is executes. Okay, now we are going to study more detailed about the processor. Okay, processor is nothing but CPU, central processing unit. It is also called central processing unit. Central processing unit. So it is processes data, taking the instructions from the user and executes the program. Okay, so in order to process, what should it contains? Processor. So what does it contains actually? So you can understand actually. So processor is, you can also intuitively think and what it requires actually. What does a processor require actually? See, it has to perform operations like addition, arithmetic operations, and logical operations. Arithmetic operations, you know that addition, subtraction, these are the arithmetic operations. And logical operations. Logical operations is nothing but Boolean algebra operations like AND operation, OR operation, exclusive OR operation. Those are the logical operations. Greater than, equal, less than, these are also arithmetic operations. Okay, shift left, shift right, like these things. Okay, so first it has to perform all these things, so that it has to perform. So first it should contain, what should it contain? An arithmetic and logic unit, so that it can perform the arithmetic and logical operations. Okay, because computer has to process the data. Okay, so it should contain arithmetic and logic unit so that it can execute all the arithmetic instructions. Okay, and it should have some registers. Registers are nothing but memory elements. Those are also like memories. What is the purpose of registers? Registers means in CPU there are some registers. Registers means it can have multiple advantages, multiple purposes. See, for example, there are some registers which can store the intermediate results. For example, if you are doing a multiplication, binary addition, something, there are a lot of intermediate results will come. So those results has to be stored. For that purpose also we need some registers. Okay, registers are nothing but memory locations, storage elements. Okay, we should not confuse actually. So in registers there are found for intermediate results. Final result anyhow it will store the output or it store in the memory. Okay, but intermediate results, to store the intermediate it require internal memory, small internal memory. Okay, and some other instructions, some other registers too. For example, there are registers we study in detail actually. What are the different registers we study in detail? Okay, registers. Okay, we'll study registers in detail. Okay, next, control unit. Control unit, this is the heart of the computer, you can say that, heart or brain of the computer. Okay, because it controls everything. For example, it reads the instruction either from input or from the memory. It takes the instruction. Okay, instruction means it's also in terms of, instruction is nothing but, it doesn't different, instruction is nothing but it is like, for example, it's a memory location. It's like it contains opcode. Opcode means in terms of zeros and ones only. Okay, for example, 110, if it is indicates, if the processor is designed such that 010 add instruction, I mean if the opcode means operation code, if the operation code contains 010 means it will generate the signals in such a way that arithmetic and logic unit will perform the add operation. Okay, it also contains addresses. Addresses means see that addresses means, what does it means? That this is entire instruction code. Okay, for example, addresses means from where the in which location. Memory means there is a lot of locations will be there. We'll study more detail actually. Okay, so which location it has to take the data. Okay, so for example, some 100 location or memory it is mentioned, so that control unit will pick up the data from the 100 unit and it will place in the temporary registers here. Then it will do the addition. For addition we require two inputs. Okay, it will also fetch the second and place in the temporary registers. Then it will decode this op code. 010 means addition, for example. So it will generate signals to the addition such that arithmetic and logic unit will act as a adder. It will behave as a and it will generate results. And again, after generating results, what you should either display in the output or it again stores in the memory. Okay, so control unit is the heart. It will fetches, decodes, generates timing signals, coordinates all the activities. So it is heart of the computer. Okay, it's like everything actually. Okay, so one of the most important thing. Okay, next we will study that in CPU we will study more details. CPU we will study more in more detail.